Okay. So I'm going to dazzle you with all kinds of shiny things. So hopefully you won't ask me any real tough questions. I started a couple years ago. I had this idea and did a little skunkworks project, and I showed it to Brian and his management staff a few weeks ago. And all of a sudden they're like, "Oh my goodness, that's cool. Let's go show this to this forum today." So hopefully nothing blows up. The demo I'm going to show you is with it's real data that's been recorded, and I'll go through the demo, and then Lord willing, I'll go over to do live stuff, and so you can ask me to press buttons, and we'll change data rates and stuff. And hopefully the demo gremlins don't bite today. But what I'm going to start off with is show you this this tab here. So, I already started the workloads. All right. So I have a whole bunch of stuff on here. On the top is how much power we're using on this system. So right now I'm running about 440 watts, and then the next thing is histogram of that. So this has been running for a while, and then I have this is an older platform, one I had in the lab and was just using. It has 2 CPUs on it with 36 cores, and each of this is the temperature of those. And then I have I think I have 6 or 8 fans on this thing, and this is the average RPMs on those fans. So this thing is hot because the CPU utilization is 100% for almost all those cores, and therefore down here is the CPU frequency. Right, so these particular processors are a little bit older, and their CPU frequency range is 3 gigahertz down to 1 gigahertz. And of course, the way the power management stuff works, you can't run them all at 3 gigahertz. That's why you see a little bit. Some of them aren't quite at 3 gigahertz. Some of them, it's close. And then at the bottom here, I have 4 workloads that are running. These are containerized DPDK applications, all running SRIOV. So I'm going to briefly give a quick overview of what that means and why the system is doing what it's doing. So let's see if I go to the right slide here. So DPDK. So traditional in networking, your data comes into your NIC. It's DMA'd up into the kernel. The data is DMA'd into the kernel space. An interrupt is fired. The kernel will go grab that data. The network stack in the kernel will grab that data. It'll do what it needs to do, like out of packet ordering and packet fragments, all that kind of stuff. Finally, it gets the packets it wants, and then it copies that data up into user space in the form of a socket, and the application uses it. Your web browser, looking at cat videos, whatever. That's all normal stuff, right? And that works well for 50 years now. However, with DPDK, what we do is we want to be much lower latency and be able to do as much packet processing as possible. We're doing like VNFs, right? You have your virtual firewall or whatever. And we can't rely on those interrupts because if you're doing small packets at 100 gig, you're at how many?
148.
148 million packets a second, which you just can't have that many interrupts and do any real processing. So what DPDK does is instead of having the kernel involved, what they do is they allow a user space application to actually directly access the hardware. So that data is now DMA'd directly into user space and with an application, and we usually use DPDK as a way to do it. And what DPDK does is it has access to all these descriptors, which just rings in the NIC, and it basically says, hey, do you have data? Yes. Okay, I'm gonna read it, I'm gonna go process it. Do you not have data? No. Do you have data? Do you have data? It just is constantly polling for data. So even if there's no data, those cores are running 100%. So it's very fast, but if there's no data, it's not very efficient. But if there is data, it's really fast, right? So it's this interesting trade-off. So that's why we have what we see here on my box is I am actually sending data as fast as I can on these things. And here's the RX and the TX on these things. So yeah, I just have each one of these VNFs. I'm running 8 cores per instance. These are actually containerized DPDK applications, just test PMD. And so I'm just reading data, and I'm just doing some manipulation, and I'm spitting it back out. So right now, those cores are being really well utilized. But if I drop the packet rate, actually, let me just drop.
The 34.5 gigs a second?
That's a million packets a second.
Okay, I was just trying to understand what
the
metric was.
Sorry, I forgot to.
Is this some odd conversion?
Yeah. Like what does this number mean exactly?
I got a little flustered. I saw my reflection in my head somewhere, and I was like, what happened to my hair? So yeah, that's what's going on. And here I have some bar charts, right, showing my data rate is 100%, and this is the core utilization rate, or the CPU frequency for all the cores in this VNF. So if I am to drop the frequency, so I'm just going to drop the frequency on these. I'm going to drop it down to, actually I'm going to do this. If I drop the data rate, so now I'm only doing like 75% of the data, right? So I dropped how much data I'm transmitting to each one of these VNFs. And you'll notice that the power didn't change, right? Nothing changed, because those cores, even though they're not near as busy as they were, are still going at 100%. So the frequencies are still at 100% because that's the way the frequency was. Hey, how busy is my CPU core? Oh, I need to make that frequency as fast as possible. So we do have knobs we can turn, and we can change the frequency. So I'm going to drop the frequency on these things all the way down to a gigahertz, or 1 gigahertz. And you'll see that our power, it takes a few seconds for the telemetry to come up because the BMC only updates my data every couple seconds. You'll see the power starts to drop. I mean, that's a pretty stiff drop there. However, I'm dropping almost half my packets. So, that's probably not what I want. So it's okay. Well, let me try a different one. So let me try 25%. Okay, this is better. I'm getting close. I'm not dropping all my packets, and the power is going to creep up a little bit, and the temperature a bit, but that's still not good enough, right? So like, okay, let me try 75% or 50%. I don't have my glasses on. So at 50% with that data rate, you'll see, okay, I found a pretty happy medium. I'm saving power. I'm saving over 100 watts right now over what I was doing with this amount of workload, and I'm not dropping any packets. So what that tells us is, hey, there's this balancing act that can happen, but it can't happen without insight from the application. These are containers or VMs that are running, and what we needed is we need to have them tell us, hey, how busy are you? What we need is some insight, some telemetry from the application to know how busy that thing is in this case, and somehow feed that back to something that will reduce the core frequency for this specific example. And we actually can do that. We have this, let me turn on my business indicator here, show busyness. So I have this little bar graph here, and here it shows how busy it is. So if I crank this thing back up to 100%, I'm going to restart all my workloads again, and you'll see them jump. You'll see that the busyness is they're very busy, right? They're all at 100%. They're or almost as 100%. The calculation isn't quite right. But if I drop down the data rate, you'll see that the busyness indicator starts to drop a bit. So the question is, how do we get that busyness indicator to make these intelligent decisions? And this is not a new problem. I did a demo several years ago over here, and I'll show you what happened. So the way demo I did a few years ago, and I have a link to a YouTube video here in a second, is that we have these workloads that are running, and normally you launch them in a container or a VM, and when you launch them, you have to give them information. My own tool, and I forget which button to put. You have to, these workloads can send this telemetry data. In this case, it's how busy it is, right? Because it can calculate, I did 1,000 cycles and I processed data once, or some percentage, right? And it's going to send that off of the system to some database someplace. Like the one I used was InfluxDB. So these VNFs, these applications will send this information off to some database someplace, and then some analytics will analyze the data and say, hey, I think based upon what I know about that system, I think you can drop this core to this frequency, not drop any packets. So I did a demo on this several years ago, back in 2019, before everything changed. And it worked pretty well. But the main drawback from it is that the loop was pretty slow. Right? The data had to be, not only have to provide credentials and tell the VNFs where to send the data, but it's kind of slow, right? I mean, really, in realistic terms, right? It's like a 3 or 4 second turnaround time before you could drop the frequency. And in the workloads that some of the customers I was talking were doing, it was a very predictable workload. It was a cable company. Of course, that was pre-COVID, but in the mornings there wasn't much traffic. or there's the spike in traffic, and then everybody went to work, and it all dropped, and so they could use this information and they could reduce their power utilization on the cores, and it worked out pretty well for them. But in unexpected things, it didn't work so well because it wasn't, it didn't handle bursty stuff.
It's one of the, like, we deal with power management issues on our servers, and yeah, that's one of the trade-offs we've been dealing with is we can turn them down, say, when they're not delivering a lot of traffic. And because our traffic patterns, they sort of follow a diurnal pattern, typically you'll see them go, but then there'll be some big release will come out and traffic will just go from nothing to max. And I kind of can't turn my servers down. I want them to run them at lower power when I need to run them at lower power. But if I do that, basically they take too long to respond.
Yes.
Like, and it becomes a real problem. So yeah, it'd be interesting to see how you can.
So there's a couple things Intel's doing. So I have, what I'm going to show again is a technology preview. It's not we don't know when it's going to be a product. But also in the later generation processors, I have some data here from our Sapphire Rapids, the latest generation. They are making it so that the core frequency adjustment is much more responsive. So in the systems I'm using here, it's kind of slow. It's like, hundreds of nanoseconds kind of a thing. I probably used the wrong term. Not enough coffee today. But the newer ones, it's much more responsive to be able to do this kind of stuff. So,
and that's what I wanted to ask too, along that vein is, how real time does that need to be? Are these database processing workloads, are they having to happen at the edge as well?
So this isn't necessarily an edge thing, but it could be.
Okay.
It depends on what you want to do with it. So I'm going to explain to you how I'm doing this without sending any data off of the platform, but still provide an OS agnostic method to be able to provide that telemetry data to a local agent, right? Because you can do it. There is some work in DPDK that will do this. It'll provide some data over a virtual serial interface, but it's your hypervisor or your base platform very specific to that, right? You have to have a VirtIO serial device, which I can't run on Windows or something like that, right? So what I have is I'm going to show you what I've done.
Where's the delay? Is it the latency introduced by the setting, the throttling, or is it the round trip time to?
I think it's the round trip time. So the data has to be collected and sent off, right? And let's say that happens once or twice a second. And then it goes to a database, and then you have something there that's collecting the data and trying to analyze it, and then it has to make a decision and send it back, right? So it depends on how tight a loop you want to do that in and how far the database is and how complicated the data analysis is. But in the test that we did with the database we had, at least at the default parameters, it was a good 2 or 3 second round trip before the changes would be affected. So if I drop the data rate on one of these to 0, it would take a while, relative terms, a long time for that to come back and say, yeah, let's change this. You can drop your frequency.
So spiky load is really a issue.
So what I've done is I had this interesting idea, and I got some really smart people to go implement it for me. Is I came up with this idea called a telemetry pipe. So, I forgot to talk about SRRV. Sorry, go Google. If you don't know what SRRV is, that's what Brian and I are actually most well known for. And in the presentation, we have links to videos and stuff. But SRRV is a way to provide direct hardware into a VM, or in this case, a container with DPDK. So with these containers that I'm running, or it could be a VM, doesn't really matter, we're running DPDK. And with that, what we did is we created a hardware-based mailbox so that the DPDK application can write, because it has access to the hardware, right? Because it's in this SRRV little piece of hardware. It can write a message that gets routed over hardware down to the physical device, and then it gets routed back up to our controlling driver, the PF driver, the physical function driver. And so what I do is I have the demo, and what I'm going to show you is that it will take this piece of data. I don't really care what it is, but I happen to be sending the busyness. And I send it, and then I will read it with some local application. I just created a generic netlink interface to the driver, and I have a little Python script. I just go read it, and I'm reading it 4 times a second. And you can make it faster or slower, whatever you want, but that's the data rate that we're pumping the data. I'm reading it at 4 times a second. I go read the data, I go look at what's going on, and I adjust the cores accordingly. So it's a much more reactive thing, and it's OS independent. I'm just sending, the only thing I would care about is the DPDK application just needs to know how to send this over this channel, over this mailbox mechanism we have.
Can I ask a quick question?
Yeah.
Sorry. I want to make sure I'm understanding exactly what's happening here. So the layers that you have there, you say it's OS independent. What I'm actually trying to figure out is where is that being processed in hardware? If it doesn't involve the operating system at all, and you've got the containers for the host operating system, is that running like in CPU?
So what I mean by that is that there are other mechanisms where you could have the container or the VM sending data down to your hypervisor
Right.
or your host OS, but that's going to change depending on what hypervisor you're using.
Right. Okay. I'm
And
tracking.
since this is talking directly over the SRV interface, and it's not a socket, it's just a hardware mailbox that is writing data to, a blob of data, it's independent of the OS. Right? It doesn't care what OS is there. It's
Got it.
because it's writing it directly to the hardware.
Yeah, I'm tracking. But this is a thing you will have to be running on the operating system to take effect.
Oh, you'd have to write your own application here to go get this, because it's. I mean, I just did this business indicator, right? But where I see this could be interesting is especially in the comms market that's using these DPDK things, they might want to send different telemetry, right? The busyness is one thing, but it could be something else, right? You may want to adjust your cache dynamically or some other indicator, right?
Sure.
So you could pass that data. So your analysis engine there, again, I have a simple dead stupid Python app that does this, will analyze that data and know what kind of workload you're running, right? Am I running a video analytics tool, or I'm running a DPDK application that's really compute and I/O hungry? Then I'm gonna make changes to my platform with all these knobs that I can turn based upon that information, and it's all local.
Well, you said that it's OS independent. The pipe is OS independent, but the application that's reading, that's because you're using a netlink socket to read it. So that's a
in this example, yeah. But if I was doing it under ESX or something else, obviously be very different, right?
Right. Okay.
Tracking.
Yep.
Thank you.
Yep. Okay, so now let's get to the fun stuff. Okay, so I'm going to change this to my other control panel down here. And now what I want to do is now I have to turn on my auto adjust, which is this. So now I'm turning on that Python script that's going to be analyzing this busyness data, right? All right, you guys got a chuckle. That's good. His hair's gone too. What's up with that? Okay, so I'm going to actually I'm going to turn it off so you can see, because that's kind of fun. I'm going to turn off the auto adjust. I'm going to do this. So right now I'm going to make. Hopefully it'll kick in. There we go. So the first VNF here is running at like 80%, and this one's at 70%, and then they're all running at different rates, right? And you can see that by this bar chart, or by this graph here. But again, all the CPUs are still around 100%. So now if I turn on, I start doing this analysis.
Sorry, what is the sampling rate on the thing that's reading?
4 times a second.
4 times a second.
Yep. And you can make it faster if you need to, right? It'll just burn more CPU cycles to do it, but it's still a lot faster than you're going to be able to do going off of the device, right? So I'm going to start my auto adjust here, and this thing's going to start saying, "Oh, okay, I can start adjusting some of these cores. So let me start doing that." So it does a little analysis, and it starts to drop those core frequencies, and depending on this busyness indicator, and as you see, especially in this right one here, it was way down here. And now it moved up. So as I drop those core frequencies, now it's not polling as fast because the cores aren't running as fast. And so the busyness indicator starts to go up. And so I do this core adjustment until this simple busyness indicator that I calculate is as high as possible without going over a threshold. And what you'll see is that the power dropped as soon as I turn this on, right? We're saving 100 watts of power. And the cooling, and of course that's just on the platform itself, and on this synthetic workload. Now you're going to be pumping out less heat in the back of the system too, right? Which I think you guys all have even much more experience than we do about this, right? And that's even a bigger cost, right? So we think this is kind of cool, and we can, I can adjust the different things, but that's the basic premise. Is like, this is a mechanism that I just came up with, and I said I got some smart people to go implement. And we're looking at targeting this for the comms market that do these polling, this DPDK applications, because no matter what, those cores are always at 100%. So, and you could write your own algorithms using ML or whatever, buzzword of the day it is, to adjust those cores. You can leave a nice little buffer in case oh, it's a certain time of the day. We know we're going to get bursty traffic, so I can adjust them a little bit and get ready for that kind of stuff.
So have you done any auto adjustment based upon a thermal correlation for like polling, like the amount of heat?
No, but you
temperature,
could, right? That could be one of the factors you do, right? You could also just you could just cap a VNF and say, I'm only going to run these at a certain percent, and I'm going to create more of them in other areas, right? If this isn't a high priority workload, I'm going to spin up more of them on systems that are maybe a little bit more latency, but I'm going to put them over here where there's more sun, like what Brian was talking about, right? But this is the point of this demo is to show you that there is a mechanism. Hopefully there will be a mechanism available that is a local interface where your application can provide those insights. Because today, those containers and those VMs are really, without some unnatural acts, are really isolated from the host OS in providing this feedback, right? Either you have to send it over some proprietary interface or send it off the box and have some analysis done. So this is just an interesting, we think it's an interesting way to be able to provide this feedback. And the most dramatic way to show that off is this power savings. I'll pause here for some questions, and I think we're running out of time, so I won't go to the live demo unless you really want me to push my luck here.
Come on, we want to see.
Just throw the dice.
Just for a minute.
I'll speed up my stuff.
All right, so here we go. I'm going to start. There's nothing running right now, so I'm going to start sending traffic. I'm going to start up my workloads, my 4 containers. Hopefully they'll all spin up. Oh, all right. Yep, they're all spin up. So you see all those now that everything's back the way it was, everything's around 100%. So if I drop the core frequency over here, please don't blow up. You can see I can drop the core frequency, but I'm dropping traffic, right? Or I can drop the data rate over here. I can turn on the busyness indicator, so you can see that. So I'm going to drop my data rate down here, and you'll see that I'm not pumping a lot of data, and so my application is reporting I'm not very busy, right? I'm spinning lots of cycles doing nothing. So you could do something interesting to me. And if I turn on the live version, please don't blow up. You'll see that it should adjust that one VNF's core, because it's the only one that's there you go. And if
Hang on, is that tab you just selected labeled fun stuff?
It is, yes. But I don't have my glasses on, so I can't see it. So that's my excuse. So because I think it's fun to see this little guy sitting there. So that's the live version of the demo. Again, it's just something we're trying to forward think about how to do some interesting stuff. And one of the problems is, how do you get reliable data in a fast way from your application so you can do this kind of feedback, right? And this is something that I've been playing with.